Hello, good morning. My name is Pierre Kunga. I'm going to present to you the acetyl-salicylic acid, known as aspirin, commonly used for pain. How to calculate the formula, the molar mass of the acetyl-salicylic acid. We know the formula is C9H8O4, and that means this formula have 9 carbon, 8 hydrogen and 4 oxygen. So we're going to compute the molar mass of each element. We know the carbon is 12.0.1, the hydrogen is 1.008 and the oxygen is 16. So we're going to compute all the value to have a molar mass of 180.154 gram per mole. That's the molar mass of the acetyl-salicylic acid. Now, what is the geometry around each atoms except for hydrogen? The Lewis structure of the acetyl-salicylic acid is shown as we can see on the PowerPoint. So we have, I have labeled all my atoms from 1 to 13. So around the atom from 1, 2, 3, 4, 5, and 6, there is 3 bond and 0 lone pair. That means it's trigonal planar, the electron geometry, and the hybridization is sp2. And the atom 7 have 3 bond. That means the electron geometry is trigonal planar, and the hybridization around this is sp2, 3 bond with 0 lone pair. You have the atom 8. The atom 8 have the atom 8 have 3 bond with 2 lone pair. 3 bond with 2 lone pair. That means the electron geometry is linear, and the hybridization is sp2. The atom 9 has the hybridization sp2 with 2 lone pair. The electron geometry is bent. The atom 10 has the hybridization sp2 with 0 lone pair. The electron geometry is trigonal planar. The atom 11 has 4 bond with 0 lone pair. That means the hybridization is sp3 and the electron geometry is tetrahedral. The atom 12, the hybridization has a 4 bond. That means with 2 lone pair, the electron geometry is bent, V-shape, with the hybridization sp3. Following our PowerPoint, in summary, we have 21 bond. That means 21 sigma bond, and we have 5 double bond. That's pi bond. So you have 5 pi bond. So the delocalizer electron is in the oxygen that can move each side to stabilize the force. Yeah, the localizer electron is in the oxygen who can move, who have one bond, who can move either side to form the double bond to stabilize the energy spread. The solubility in water and the acid property of acetyl-salicylic acid. Acetyl-salicylic acids have the bond COH, who have the polarity function. So the oxygen will move to form the hydrogen bond with water and dissolve with water. So as weak acid, acetyl-salicylic acid will give off easily the hydrogen atom to ionize. So as acid, acetyl-salicylic acid can conduct electricity and it can dissolve in water. That's the property of the acid. It can react with metal to produce hydrogen, react with base to form salt and water. So acid have a sweet taste. Now, how to calculate the concentration of the acid? We know the mass of water equal the mass of the patient times 0.6 because we know the mass of a human being is made up of 60% of water. So the 60% of the weight of the patient will be the weight of the water. So we're going to convert first 160 pound in gram. And we know 1 gram is 453.692 grams. So we're going to have to convert it into gram. We're going to 160 pound times 453.592 gram per pound equal times 0.6. So you're going to have 400. You're going to have 435.44.83 grams. That's the mass of water. Or we know the volume of the solution is equal to the volume of water, knowing the density of the water, which is 1.00 gram per milliliters. So the volume of water, that's we have the mass of the weight, the number of gram of water. So knowing the density, we know the density is equal to mass divided by volume. So we have the mass of water, we have the density, so we can do the math and have the volume. So the volume of water equal to its mass here, that is 435.44.83. Now we know 35 milligram of aspirin ingest equal to 0.25 gram. So the number of mole going to be the mass of the acid divided the molar mass of the acid. So the mass of the acid ingest was 0.325 gram, and the molar mass, knowing previously calculated, is 180.154. So the number of mole equal 1.8 times 10 exponent minus 3 mole. So to know the concentration of the acid is going to be the number of mole of the acid divided by the volume of the solution. So the mole we just calculate now, 1.8 times 10 minus 3 divided by the volume of the solution was 435.44.83 multiply by divide by 1000 to have to convert the milliliter in liters. So you're going to have the concentration of 4.13 times 10 exponent minus 5 mole per liter. That's the concentration of our acid. Thank you for listening. Thank you. I have a great day. Pierre Kunga.